Good evening, everybody. From another warm, gorgeous evening in the Death Valley region. My name is Mike Jerry, and got some more astronomy stuff to see tonight before the moon starts heading into its light phase again. Just a beautiful crescent heading over the horizon to the west tonight. Really nice. Hope you're taking a peek out maybe and taking a look at it as well, because it's really a sweet one this evening. But we got some more. I just want to kind of finish up our little galaxy sweep that we started last month, and May is also part of the galaxy season technically, so I wanted to take one more shot at that and kind of clean up the best of what we got left of that, and we could say we've done our full galaxy season over the last couple of months, because we did, I think, 4 sessions in April. That was all the galaxies, and then switched to the color camera the last couple of times, and did some of the Cloudy Nights challenges, which were great. And now we're going to finish up with some galaxies. So let me turn off the test pattern and bring up my setup. And so this is the setup that I am using tonight. Zoom into the important part here, which is the telescope itself, which is a 6-inch f4 imaging Newtonian, and the focuser eyepiece holder appears where the camera is stuck in, and it's all riding on a Celestron Evolution AltAz mount that's then on a Celestron HD Wedge that is now on my cinder block pier that's sitting out in my backyard, and the pier and the wedge stay outside permanently polar aligned. The mount and the telescope go in with me at night because these bottom two things are, the wedge and the cinder blocks, are pretty impervious to the weather, even the high heat that we get here in the summer, so they spend their time outside and they're fine. But these have electronics and optics and other sensitive things in them, so they have to go inside at night. And it all connects to this laptop you see back here in the background on this table, which is where I'm sitting right now talking to you. And that's what runs it all. So, good evening, Jeff. Thanks for stopping by. And let me get this out of the way here. Cool. So I can see what I'm doing over here. So that's what I am using, as always. And so let's see. Right now I am on Denebula, which is the tail star of Leo the Lion here. You can see from Leo's mane and his body and his hindquarters here. And so we did, last month, we did this whole swath of galaxies in here. And in fact, I should bring up, here's all the galaxies we did. Quite a bunch. So I'm going to highlight them and close this. And so this is all the ones we did in here. So quite a bunch. But there's still a few down here near the bottom that are still pretty nice, and right now they're nice and high in the sky, almost as high as they get this for the entire year. So we're going to kind of sweep through and just to clean up and do the kind of the best of these down here with what we've got left this evening. So let's take a look and see what we've got here. So the best thing to do is go through and look and see how big they are. This is a 6 arc minute by 4 arc minute. That one's a pretty good one. And this one here is a 3 by 1. So they are, but we have a big enough sensor that we can do both in one shot. So that's what we're going to do. We're going to center right on that star, send the scope to it, and see if we can't get right on it and get both of those in one shot. Well, there's one there. I'm not really seeing. Okay, so there's that bright star and probably that bright star. Yeah. So brighter, dimmer, and dimmer in kind of a 90-degree angle. Brighter, dimmer, and dimmer in a 90-degree angle. So this here is going to be this one here. Yeah, it's going to be the fainter one. I'm sorry, this is the brighter one, this is the fainter one. So yeah, so that should work out just about right. So let's just fire it up. Start imaging. Oh good, the clouds finally lit up for you a little bit, huh? That's pretty cool. Okay, so we have, you need to fold out of the way, and you need to fold out of the way, so we get a better look at. Let's clear this out. For some reason that didn't clear. Okay. Not sure why we're still looking at a picture here, but it looks like the first sub-exposure is building in here. And so what we've got here is NGC 4469. Huh, the bigger galaxy doesn't have an NGC number, it has a PGC number. The Peculiar Galaxies Catalog, PGC, is usually the smaller, fainter stuff. In this case, looks like the smaller, fainter one seems to have the number, and the brighter one does not. Well, this is a mag, it's bigger, but it has a mag 15. Ooh, with a surface brightness of mag 18. Ooh, this is actually very, very faint. But they're calling it a 6 arc minute by 4 arc minute. That's pretty interesting. This one is much smaller, but much brighter. Mag 12.6 and a mag 13, almost mag 14. Well, anyway, let's see what we can see here. Oh yeah, look at that. There's another one there. Oh yeah, see, we've got one there. There's another one here. And here's one here, and here's one here. So we got a whole bunch in here. Again, I have my filters turned on so that I'm not seeing all of the fainter galaxies. Otherwise it just gets way too much. The whole screen fills with red and orange and blue ovals. But yes, we've got quite a few galaxies. Looks like we caught the very edge of one over here too. So we definitely have some galaxies going on here. So let's turn my enhancements on, which sharpens things up a little bit, makes them look a little bit better. And yeah, that looks good. Yeah, those numbers actually look really good. Okay. Yeah. What target am I on, Jeff asks. NGC 4469. So we're right around Virgo right now. There's Virgo. We're between Virgo and Leo, kind of finishing up the swath of galaxies for galaxy season that we started last month, and we're going to get a few more in here. So this is 4469 is what we're on right now. Oh yeah, an M49, a couple of nice ones below here, so we'll get those next. But 4469, let's see if Wikipedia has anything interesting to say about 4469. Spiral galaxy is an edge-on spiral located about 55 million light years away, so it's not too far away, but it's not in our local. It's also classified as a LINER galaxy, discovered by astronomer William Herschel in 1784. LINER is Low Ionization Nuclear Emission Line Region. LINER is a type of galactic nucleus that is defined by its spectral line emission. It has an X or peanut-shaped bulge, betraying the presence of a bar which generates such a structure. So if you can, we'll get a couple of more subs on here. Well, actually with 4 we should be able to see. So the bulge doesn't really make an oval, it's kind of square. So it kind of mushrooms up a little bit here before heading to the outer reaches of the galaxy. And that peanut shape, or bow tie shape, I guess you could say, indicates that it's most probably a barred structure. But there's quite a few galaxies in here. You got another one over here. Almost like a face-on spiral that we're seeing there. And there's another one here. Possibly another one there. Definitely one here. But that's the PGC that we're... This one here is the PGC one. That's this one here. PGC 41036 is that little puff right there. This one here is certainly brighter than that. I wonder why that's not... that's actually a very interesting shape too. Look at that. It's a barred galaxy that has just wispy arms just sticking off it like that. Kind of just straight away almost. Kind of like an S-turn. Well, this bright one here is about 50, what did we say, 55 million light years away? So these are all probably in the same neighborhood. Pretty nice, though. Oh, you got wispy high clouds, Jeff? All we had today was breeze, and the forecast wasn't clear whether it was going to stop in time for our soiree tonight or not, but it did. So, thankfully, it's just a gorgeous, calm, warm evening. Cloudless sky, typical desert late spring evening. I'm just in shorts and a t-shirt, and it's nice and warm. It was a bit over 100 today, and it's supposed to be about the same tomorrow, 102-ish, give or take, 103-ish. We're starting to get warm, and so tonight is just really nice and warm and calm. We get our best nights for astronomy when we're either warming up or staying warm. It's not until the weather changes, like when we're moving into a cold front, which is supposed to happen, I believe, tomorrow night. The weekend is supposed to cool off by about 10 degrees, which will be nice during the day, but it means wind and stuff. So tonight may be my last night for this dark of the moon cycle, because it's going to be windy tomorrow night, and then by Saturday night the moon is going to be too big and rising too late. Let's get the background music going here, so that all of you who are close to bedtime can just be lulled off to sleep. You know, I figure if I can lull you off to sleep with your eyes filled with stars, I've done my job. So, enjoy the music. Let's see if we can see any more detail. This one out here is really interesting. I mean, looks like another barred spiral that just has the arms splaying straight out on it, like it hasn't been rotating much. Definitely an interesting shape. I wonder if I can let's get a number on that, see what that one is. Whoops. We need to be here. And so to do that, I'm going to need to turn off my filters. Doing, 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 doing. Okay, so it's down here. I guess it's going to be this one. Yeah. Boy, I'm surprised it's just a PGC. It's a bright sucker. Mag 14.7. PGC 41292. Looks like it should be brighter than that. I wonder if it's actually NGC 4488. It's not. It's too close. No, it's got to be this PGC. PGC 44609. Well, let's see if PGC 41292. Oh, and we got photobombed by a satellite. Let me see if I can. 41292. Let's see if PGC 41292. No. No, Wikipedia is not going to have something that esoteric. But it looks like that's what it is, according to Stellarium, anyway. Although it looks awful bright to be just a PGC catalog galaxy, but there you are. And there's 10 minutes on those. So let's move on to the next little batch down here. Next target. And okay, add the bookmark. And you add the bookmark. Highlight bookmarks and go. Okay, and now let's head down here. I probably can't get both of those in the same, so we'll just do M49 next. This looks like a just a good old-fashioned elliptical. Alright, let's start imaging 183. Alright, so this is going to be M49. Looks like just a big old elliptical galaxy. M49. SEA 49. Okay. Is a giant elliptical galaxy about 56 million light-years away in Virgo. It was discovered by Charles Messier himself in 1777. So it's a giant elliptical. As an elliptical galaxy, M49 has the physical form of a radio galaxy, but it only has the radio emission of a normal galaxy. The nucleus is emitting X-rays, suggesting the likely presence of a supermassive black hole with approximately 565 million times the mass of the Sun. Yikes. The galaxy has many globs, estimated to be about 5,900 globular clusters. Just for reference, the Milky Way has somewhere between 150 and 200, so this has almost 6,000. On average, the globular clusters of M49 are about 10 billion years old. Between 2000 and 2009, strong evidence for a stellar mass black hole was discovered in one of the globs. Interesting. One of the globular clusters has a stellar mass black hole. A second candidate was announced in 2011. It is the most luminous member of the Virgo cluster of galaxies, and more luminous than any galaxy closer to the Earth. This galaxy forms part of the smaller Virgo B subcluster. M49 is gravitationally interacting with the dwarf irregular galaxy UGC 7636. The dwarf shows a trail of debris spanning roughly 1 by 5 arc minutes, which correspond to a physical dimension. So perhaps this one here. It's gravitationally interacting with UGC 7636. Over here, you. UGC 7636. Well, I'm going to assume it's this one. We got another galaxy down here, though. And let's Turn off our filters and see if we can find 7636. Whoa. Wow. That's quite a few. Well, there's quite a few galaxies in here. Look at all those. So a lot of these are galaxies. And where's the... We should be fairly much the same. So these yeah, so there's a double star there, which is probably the double star here. Although one of them looks like a galaxy, so these are, a bunch of these are actually galaxies, not stars. Huh. That's interesting. But anyway, this is a giant elliptical. So this is a really big galaxy, which is why it's one of the brightest closest to us. Let's adjust our histogram, because that clearly is out here. Hey, Ollie. Glad you could stop by. It's, we're at the time of the year where it's not such a terrible, so what is it, like almost 6:30 in the morning for you right now? I forget whether you're, it might even be 5:30. I forget whether you're 7 or 8 hours ahead. Or actually, maybe even 9. You're either 8 or 9 ahead. So it's either 5:30 or 6:30 a.m. for you right now. But good morning anyway. And Curtis, you said the Coma cluster. Well, we can go look for that. But there's a whole ton of galaxies in here. Yeah, you can see now that I've turned the contrast up. You can see that's definitely a galaxy. This is definitely a fuzzy galaxy. This is definitely a fuzzy galaxy. This one's definitely a fuzzy galaxy, and this one. And I think this inner one is, which is, yeah, the inner one of these two is actually a galaxy. You can see it is a little bit fuzzier. You can see how this star is much sharper, more defined. This is a bit fuzzier. You can definitely see the fuzz balls in here. Tons of galaxies. Ooh, laptop need food. 6:22. Yeah, you are 9 hours ahead. Yep. Well, good morning. Yeah, there's quite a few galaxies in this shot. Alright, let's turn those back on. Yeah, see, here's right here. This is probably the one it's interacting with. Where's the Coma cluster? Coma cluster. 115 degrees, so it's about east. It's 71 degrees, so that's... That was one that we just missed, so we'll go do that one next, Curtis. Hey, Pete. At the new digs in Vegas, huh? Good for you. Glad you could stop by. Oh, come on, you. into here. This is where we gotta go, down here. There we go. How are you liking your new place? There's quite a there's quite a cluster of stuff in here. There's quite a few galaxies in here. These two, hopefully, we can do together. That's a pretty good one, though. Lots of little galaxies around it. Fuzzball, 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 fuzzball. Look at all these little fuzzy ones in here. Definitely a... Looks like a spiral in here, possibly barred. So the dwarf galaxy here is what this is interacting with. So Wikipedia was talking about, there's definitely a galaxy there. More, there's a fuzzy ball there. Fuzzball there. There's tons of them in here. One right at the very top. Tons of them in here. Tons of them. Definitely a nice bright one there. All look like pretty much boring old ellipticals, no interesting spirals like we just had in the last shot, but ellipticals may be the least interesting visually, but they can be some of the biggest galaxies, so this one's a pretty big one. You got a pool. You got a pool with no bombers. Well, we got nice springs here, but we got the bombers. Bombers, for those of you who don't know, are large horseflies that bite right through denim. So that's one of the fun things we have to, that's unique to our particular microcosm here that we deal with. Alright, so there's M49. And let's see now if we can head down to, see if I can pick that star. See if we can center on that. Yeah, I might want to be up on this one a little bit more. Yeah, let's try that. That might work a little better. Yeah. So, looks like it's up there. This one's down here. Yeah. So I think that's probably, let me try going down just nudge it upward just a little bit. Yeah, we'll try that. See if we get them both in the same shot. Okay, so we should have both of these in here now. This looks like a beautiful spiral. This one probably also as well. We're just looking at it sort of edge on. Now, of course, we'll always see what we can see for other galaxies in the background. Yeah, actually, Curtis, while you were away, I found it. And once I get done with this little group, we'll go up there and do that. It was one that was off the beaten path, I think because all of its members are so small and faint. I didn't pick it up as one of my targets. Stellarium didn't pick it up as one of my targets, but as a group, it really does look cool. So we'll definitely do that here in a few minutes. Let's see, NGC 4535. NGC 4535. Let's see. Oh, look at that. Isn't that a beautiful? Oh, look at that beauty. That is sweet. So this one up here, the pretty one, is NGC 4535. It's a barred spiral located 54 million light years away. So these are all, the Virgo group is all about 55 million or so, give or take, light years away from the Earth. The galactic plane is inclined by an angle of 43 degrees to the line of sight from Earth. It has a bar structure across the core, no ring, and loosely wound spiral arms. The inner part of the galaxy has two spiral arms which branch into multiple arms further away. The small nucleus is of type hydrogen 2, or hydrogen beta, meaning the spectrum resembles that of a hydrogen beta region. During 1999, the Hubble Space Telescope was used to observe Cepheid variable stars in NGC 4535. The period luminosity relationship for these objects yielded a distance modulus of 31.02 plus or minus magnitude. This corresponds to a physical distance estimate of 52 million light years, give or take, which was consistent with distance estimates for other members of the Virgo cluster. So, cool. And this one down here, again, this kind of looks like maybe it's an elliptical. Hard to tell. Although it's definitely, it looks like it's flattened out, sorta. But this one is just a beauty. Look at that. We'll let this get a couple of subs in, and we'll go look at that. NGC 4526. Let's see what 4526 is about. NGC 4526. Doink. Is a lenticular. Okay. 55 million light years. Yeah. The galaxies seen nearly edge-on. Morphological classification indicates a lenticular structure with a weak bar across the center and pure spiral arms without a ring. And lenticular, I believe, just indicates that it doesn't really have any well-defined arms. Lenticular is a type of galaxy intermediate between an elliptical and a spiral. It contains large-scale disk but does not have large-scale spiral arms. Yeah, so it's somewhere between an elliptical and a disk. And this one definitely looks like it is flattening out. You know, it definitely has a flattened sort of shape to it, but definitely a very spherical core. Whereas this type of galaxy here is very clearly spiraled out with some beautiful arms. That's just gorgeous. That thing is just sweet. Getting a little ovaling on my stars. Probably means I need to check my polar alignment. I haven't done that in a couple of months. So, probably just have a slight drift in my scope. But that is pretty nice. Good. Come visit when you're getting supplies. Yeah, Pete, gosh, I haven't been in Vegas, and gosh, when the heck was I in Vegas? Last time I came to Vegas for supplies, good Lord, I don't even remember when the last time it's been well over a year. Probably pre-pandemic was the last time I came into Vegas for supplies. But yeah, next time I come in, now that things seem to be getting better, and the new case and infection rates seem to be dropping off precipitously. Hopefully we'll be able to come in and visit you guys, check out your new pad. bring my swimsuit and jump into some cool water as opposed to the nice hot spring water we have here. That is just a gorgeous little galaxy there. Couple of nice ones. And now that we've gotten some sub-exposures piling in, we definitely have lots of other little fuzzballs here. And one up there. And one there. Lots of other candidates for the Galaxy Club. Looks like my bandwidth is going up and down again on the internet, so sorry if you're getting a little buffering. Yeah, Curtis, I'm interested to see how much of it I can see. Looks pretty nice. But I just want to see how much more detail we can pick out in this sucker. It's just a gorgeous little galaxy. You get getting some pockets now of higher energy areas in here on the spiral arms that are probably star formation or the like. Possibly a satellite galaxy up here. Maybe another one there. That's just a beauty. Cool. Well, those are nice. That was a nice little catch there. Alright. So we caught those. Add. Highlight. Close. Alright. Let's go see the coma cluster up here. Doink, right in there. Alright. Let's see how much of this we can see. So this little triangle top of stars here, I'm assuming is this one here. So yeah, that should put things right in there. So that should be right about right. Oh, another thing I'm realizing with the slightly oval stars I'm seeing is we are getting just a little bit of a light breeze here. And that may be tweaking the scope just enough to nudge some of the stars out of round. Boy, but you can see there's a lot in here, huh? Good suggestion, Curtis. Coma cluster, it's an A-bell. Huh. Cool. And no one looks at the Caldwell objects but you. Actually, Gary Hawkins did a live stream dedicated entirely to Caldwell and a number of his objects. So you're not quite alone. But yeah, the Caldwell catalog is a good one. All right, let's see what we can get out of this. Quite a few there. Okay, so we got 2, 3, a couple of galaxies, 1, 2, 3. So these 1, 2, and well, that must be this one. This one must be this one, I guess. 1 and 2 and 3. Boy, there's so many in here, it's hard to tell. There are so many galaxies in this. It is hard to tell. Yeah, go ahead. Gary definitely did a live stream. Gosh, just within the last couple of months, I think. 2 or 3 months he did a live stream that was dedicated to Caldwell and a number of his objects. So there's more than 1,000 galaxies in this. I believe it. What would happen if I turned off my filters in this shot? Yeah, look at them all. Look at them all. Just in this one little zone. There's quite a lot. And of course I don't have all the catalogs loaded in Stellarium, and even if I did, not every galaxy's cataloged, so look at them all in there. Lots of NGC, IC, PGC numbers. All over the place. A mess of galaxies. Tons and tons of them. Or as Carl used to say, billions and billions. Right, put you back out here. Tweak a little more there. Yeah, Curtis, we'll definitely zoom in and scan around once I've got... I like to wait till I have at least 4 or 5 subs in there. We're coming up on the 4th one now. Earlier than that, you're not really, don't really have a whole lot of data yet. It's getting a lot of graininess. But now it's like, get a few in there, and yeah. I mean, it's hard to tell which ones are stars and which ones are galaxies. Mostly stars will have sharp edges like this one, whereas galaxies will have fuzzy edges like this one and this one. This one definitely a galaxy. That's a fuzzy one. That one. Both of these possibly. This one definitely. This one definitely. A lot of these in here look like they're fuzzy and are probably galaxies. This one almost looks like a little bit of a spiral here. So many of these look like galaxies. That looks like it has some nice, almost a lenticular, where it's, again, going from an elliptical to a spiral, and it's got a whole bunch of little swirly arms on it. A few more sub-exposures, and maybe we'll have enough detail to pick that off a little better. And you can see down here, definitely a spiral here. An elliptical there, spiral there. Soft fuzzy patch there. Fuzzy patch, a little bit of a spiral there, possibly edge on. Elliptical, elliptical. All kinds of them in here. This one looks like it could be pretty spectacular. Another spiral, elliptical, elliptical. Possibly a lenticular. Elliptical becoming a spiral, starting to spin and flatten out. Fuzzy one, a couple of fuzzy patches up here. Definite fuzzy patch there. One there, there's a little spiral there. Little, perhaps lenticular there. Spiral, I think. Another little spiral there. Fuzzy patch. Two fuzzy patches here. Third one there. 4, 5. Lots of them. Possibly a spiral there. Quite a patch. There are definitely lots of them here. That's a busy little cluster. Push the scratch even a little more. Can I zoom into the center too? Sure. I can do that. To the point where it's grainy. Lots of little soft spots in here, which could be galaxies. A lot of these little soft spots here could be galaxies. Some of the brighter ones could be, I mean, even some of these brighter ones. That's fuzzy looking. These are all fuzzy looking in here. That looks like a star, probably. This one's a sharp edge star. These are all fuzzy, fuzzy, fuzzy in here. Yeah, I'm sure there's a zillion in here we're missing. I have Mag 19. I've actually had a Mag 20 up. I don't remember what the magnitude, the overall magnitude of the galaxy was, but it was the surface brightness of Mag 20. And So I know I can see, typically I can see to about 20, but that's about my limit. Zoom into the left of the two in the center. I'll tell you which one is Mag 19. Okay, if you want me to zoom into this one. Yeah, everything's a little bit ovaled. I think it probably is time to check my polar alignment before I do next time. Make me a to-do to do that. The 4 splotches at around 7 o'clock. So, how about that one? This one here. Or do you mean these 4 splotches here? I guess there's 4 little patches there. But there's a nice one here as well. So I think you mean these 4 here. That would make the little horseshoe, or the little bowl, or the little dish. The bottommost. So this one here is a Mag 19. Okay. Here we go. Boy, that is pretty faint. Gotta love what dark skies can get you. Cool. Well, thanks for the suggestion, Curtis. We got a good 12 minutes on that one. Let's see what we can see next. We'll get the coma cluster added to my list. Highlight it. I'll have to do this next time. It'll be on the list for next time we come in here. Alright. Now, Lost Galaxy of Copeland, we did that stuff already. Okay, M90, M61 is there. M49, which we just did. Huh, but I don't have it marked. I needed to add that one. We did that one. Okay. Lost Galaxy. Let's see, NGC 4635, 4x3. Yeah, it was a little bit dim for us. That's 3x1. That's even smaller. Let's see about this one. Let's see if we can see this. Yeah, definitely a little guy there. See if he's interesting to look at. Give him a sub-exposure and see what he looks like. NGC 4635. Doesn't look like we have much of a picture in Stellarium. NGC 4635. doesn't seem that 4635 doesn't seem to have 4636, but not 4635. That's because it's 4365. Okay, NGC 4365. Try that one. That'll work better. Oh, wow, a whole patch of galaxies again. Not surprisingly. Again, it looks like an elliptical. Back off and stretch a little bit here. It's an elliptical located in Virgo, discovered by William Herschel in 1784. It's the central galaxy of W' Cloud. A cloud of galaxies about 6 megaparsecs further away than the Virgo supercluster. It has a kinematically distinct counter-rotating stellar core region, which provides strong evidence for the theory that elliptical galaxies grow through mergers. The mean age of its stellar population is greater than 12 billion years. Wow. And it retains a triaxial structure that has remained largely unchanged for 12 billion years. Because supermassive black holes in the centers of galaxies tend to scatter stars into chaotic new orbits, the longevity of NGC 4365's triaxial structure and kinematically distinct stellar populations indicates that it cannot have a supermassive black hole with a mass greater than a very big number. But there certainly are a ton of stars in here, that's for sure. Or, excuse me, a ton of galaxies in here. Definitely are a whole bunch. No, you don't. No, Ollie, you don't have wide FOV with the C8. Well, you could have one. Actually, you could have a wider FOV than I have if you put a hyperstar on that C8, or got yourself one of the 0.33 reducers. You could have a nice wide field of view with that. It's a nice thing about those cats. They're incredibly versatile scopes that can be used from really short focal length, wide field, fast f2s, all the way to planet-killing f25s. They're extremely versatile that way. Jack of all trade, master of none. But yeah, so mine is about 600 millimeters of focal length, so that's wider than most folks. And it also makes it faster, which is great for imaging. And by faster, I of course mean the faster the focal ratio, or the lower the number, f4 being faster than f5, the faster it collects light. So more light will hit the sensor in the same amount of time with an f4 optical train than an f5 optical train. The advantage of a slower, higher focal length, longer focal length scope is that it gets you a higher and sharper resolution. So it's great for doing planetary work and solar system work, moon, planets, those kinds of things. Objects which are really bright because they're very close to us and lit by our sun. And so you don't need to have fast light collection because they're very bright objects. And you can really focus and get high power, high magnification on them. The olifractor, that's what it was. The olifractor. Yeah, you put some pictures up just today, I think. You put some, or yesterday, your time. You put some pictures up on the May Observers Challenge, I think, is what you put a couple of new pictures up using the olifractor. Lots of galaxies in this image. Look at them all. Lots of spirals too. Well, this one was face-on spiral. Bright core right in the middle. Look at that bright core right in the middle. A nice flat disk going outside. There's another nice disk. Looks like probably an elliptical there. That looks like a sweet one. Now I wonder if this is a star in our galaxy or a supernova in this galaxy. Could be a supernova in this galaxy. Hard to tell. Could be just a star in ours. Or another smaller galaxy. Look at this, a nice little spiral down here. If I can zoom in on that sucker. A nice little spiral there, almost an edge on. This is a sweet spiral here. That's definitely very edge on. We're looking at that almost perfectly 180 degrees. Hey Al. Good to see you. Haven't seen you in a couple of streams. Jeff, well, hopefully you got to enjoy it while the clouds rolled back for a little bit. That is a sweet little spiral there. Another one here. This one you can see a little bit more of the face of it. Not quite as edge-on like this one is. This is almost perfectly edge-on. Fuzzy spot, certainly galaxy, galaxy, galaxy. That looks like a galaxy definitely up there. We got a part of it. Quite a group in here. Lots of little fuzzy spots in here. Yep, they are nice while they lasted. That's kind of why I came out here tonight. I was almost not going to because the breeze was supposed to be up tonight, but I knew tonight was going to be kind of my last shot. Tomorrow night is supposed to be significantly breezier, and then by the weekend, the moon is going to be too big in the sky. So my Bortle 2/3 skies become Bortle 3/4, and then 4/5, and you know, it's almost like not worth it. So tonight's probably the last night of this moon cycle. That's a pretty nice image, a lot there. There is a lot there. Add that, highlight, close. There's a lot of galaxies in there. You know, I think this one was a little small. Yeah, this one's a little small. We'll skip that one. So we'll jump down to M61. That'll definitely be worth it. Although it looks like it's just another swelling spiral. Well, it's called a spiral. Alright, nice little cluster there. So we'll take that. Next target. And head to M61. something in there. Okay. Let's see what this one will do. I wonder if I can reorder these things. No, don't seem to be able to reorder them. Edit. Open. No, it doesn't seem to make any difference. Okay. Alright, M61. The swelling spiral galaxy. Let's see what 61. An intermediate barred spiral. Okay, good. In the Virgo cluster of galaxies, it was first discovered by Barnaba Oriani, May 5th, 1779, 6 days before Charles Messier discovered the same galaxy. Messier had observed it on the same night as Oriani, but had mistaken it for a comet. Distance estimates to be 45.61 million light-years from the Milky Way. Oh yeah, look at that. That's a pretty cool one. Oh, look at that. Another edge-on little spiral down here. We'll take a look at that in a few minutes. Sweet. Another pretty little spiral with a whole host of galaxies around it. There's another one here. Good. As we get some more sub-exposures, and this stuff will start looking pretty sweet. M61 is one of the largest members of the Virgo cluster and belongs to a smaller subgroup known as the S cloud. It is a weakly barred spiral with the suggestion of a ring structure and moderate to loosely wound spiral arms. It has an active galactic nucleus and is classified as a starburst galaxy containing a massive nuclear star cluster with an estimated mass of 10 to the 5th solar masses and an age of 4 million years, as well as a central candidate supermassive black hole weighing around 5 times 10 to the 6th million solar masses. It cohabits with an older massive star cluster as well as likely older starburst. Evidence of significant star formation and active bright nebulae appears across M61's disk. Unlike most late-type spiral galaxies within the Virgo cluster, M61 shows an unusual abundance of neutral hydrogen. Nice one there. Nice little edge-on spiral there. That's a pretty cool one, though. M61 and companions. says try NGC 4527 nearby. 4527. Oh yeah. Okay. Yeah, we can do those two next. Looks like we can fit them both into 4527. 4x1. 4x2. Yeah. So we'll try both of those. We'll hit both of those next. Whoop. Get the right buttons here. Definitely a bright core on this sucker. Did I do 4725? Yeah, I have. NGC 4725, I definitely did do that. I keep forgetting to add date and time when I do them. So I don't remember when I did it, but I did it. That's definitely an interesting shape. Almost looks like it's being pulled out of shape too. Up here by maybe a companion galaxy or a dwarf galaxy. Maybe being pulled out of shape a little bit. See if I can relax the stretch a little bit. Maybe pick up some more of the core of that galaxy. Yeah, definitely. I'll have to see how that shows up at your end. I may have gone a little bit too. That looks pretty good on my end. We'll see what happens by the time. I'll check the stream and see if it dimmed a little too much for you guys. But at this point I can definitely see the inner core a lot nicer than before. Yeah, you guys can see that okay. Good. M61. A little over 45 million light years away. Interesting shape. Pretty even spiral, actually, for the most part. Pretty sweet. M61 and friends. Alright. Next. Okay. So now I need to select M61, but I can't select it because my scope is on it. Alright, let's move the scope to something else. Now I can add you. Add. Highlight. Go. Okay, so next we were going to go down to 4527 and 4536 per Ollie's suggestion, I believe. See if we can center right on that top star and catch them both. There's the top star, so there's one and there's the other. Yep, so I think that'll work just well. Alright. So 4527. Add it. That's 4 by 1. And 4536 is 4 by 2. Okay. Let's look up at 4536. NGC 4536. NGC 4536. Boink. It's an intermediate spiral galaxy in Virgo. It's located about 10 degrees south of the midpoint of the Virgo cluster. However, it is not considered a member of the cluster. Well, that's pretty nice. It gives a nice little edge-on spiral there, nice little edge-on spiral there. Cool. Definitely a nice spiral on this one. 4536 is definitely a nice little spiral. Let's see, what else do they say about it? Its morphological classification indicates it's a weakly barred spiral, hint of an inner ring structure, plus moderate to loosely wound arms. It does not have a classical bulge around the nucleus. It has the optical characteristics of a hydrogen beta galaxy, which means it is undergoing strong burst of star formation. This is occurring prominently in the ring that surrounds the bar and nucleus. Based on the level of X-ray emission from the core, it may have a small supermassive black hole, with only 10 to the 4 to 10 to the 6 times the mass of the Sun. So, well, you know, a little tiny thing. On March 8th, 1981, a Type 1a supernova was discovered 51 arcseconds to the northeast of the galactic center. It reached a peak visual magnitude of 12 on March 8th, before steadily fading from view over the next 2 months. No prior supernova events have been observed in this galaxy. pretty nice. Darken the background a little bit. Easiest to shift click and adjust gradually. And now let's pick this up a bit. Couple of nice companions. Ollie says NGC 4517. Oh yeah, so that's further down here. So I think what we're going to do next is we'll do this pair next. 4664 and 36. And then we'll head down and do 4517. It's nice that they're showing up in these convenient clumps of 2, so I can get 2 at a time in every shot. Very efficient. Seven nights so far in 2021. Yeah, I can relate. No wonder you're spending so much time building astro gear, because you can't ever go out and use it, so you might as well build it at least. Do something. See what else we can see in this image. Not a ton of other things in this. Definitely a couple little fuzzy patches here. A little spiral there. But really the two prime galaxies are the news in this shot. Happy to fill that gap whenever, Ollie. That's kind of why I do this. Living out here in the desert, I get skies and weather that work better than most folks. So, definitely some costs associated with living in the desert, but quality skies for doing astronomy is not one of them. Cool, well there's 10 good minutes. On those guys, that's nice. Alright. So now we'll do these two. Oh, what? Maybe this star. Both these NGCs in here. So there's one and there's the other. So let's just drop it down just a little bit. Well, let's see, which one is which? Yeah, the bottom one. I'd rather have the bottom one is bigger. So let's just do that. Just like that. Yeah, so this will have these two in there. Should be about right. 4636. NGC 4636. NGC 4636. It's an elliptical located at about 55 million light years, which given its apparent dimensions means it's about 105,000 light years across, or about the same size as our Milky Way, which is somewhere in the 100 to 120,000 light years size. Ooh, this is pretty interesting up here. Which one? The central part is circular and surrounded by an elongated envelope containing a large number of globs. This galaxy has an active galactic nucleus. The source of nuclear activity in galaxies is suggested to be a supermassive black hole that accretes material. This galaxy harbors a relatively small supermassive, black hole. So that's this one down here, about 55. But this one actually is even has more interesting visual appeal. Looks like a little bit of a barred, not really a spiral, hard to tell. Let's see what it is. It's 4664. NGC 4664. Did I use that wrong? No, 4664. Well, it doesn't appear that there is an article on it. 4665. The picture in here of 4665 looks an awful lot like it. Where is NGC 4665? Whoops, what? NGC 4665. That doesn't exist. Ah, great. Anyway, a couple of neat galaxies. should probably push that stretch a little bit. You're probably hearing a little bit of breeze in my microphone too. The breeze just picked up a little here. Yeah, that's what it looks like to me too. 4665 does seem to fit better. And the star pattern seems to be the same around it, so I'm thinking that's probably it. Oh, here it is in Wikipedia. NGC 4665 also cataloged as NGC 4624 and NGC 4664 is a barred lenticular. It's located at a distance of about 60 million light years, which given its apparent dimensions means that it is about 75,000 light years across, or about 3/4 the size of the Milky Way. Discovered by William Herschel in 1784. However, he noted a location 10 arc-minutes off the galaxy where there is no object. It was observed by him again on April 30th, 1786, noting the correct coordinates, and he misidentified it as another nebula. The fact that they are noted as the same object was noted by John Louis Emile Dreyer in 1912 in the corrections of the NGC, the New General Catalog. It was also recorded independently on April 9th, 1828 by John Herschel. It has a luminous, slightly elliptical bulge and a prominent bar with high surface brightness. It certainly is very bright. Certainly is very bright. Definitely a barred shape to it. Almost up to our 10th minute. 10. All right. And we'll get both of these added. You added. You added. Highlighted. Out. And now we'll go down to this pair. Down here. Okay, well, yeah, you don't have an object. You gotta have an object. Yeah, let's pick this star. Boink. Oh, interesting. Both of these are called NGC 4517. That's cool. No. I'm going to assume that we're on it. Been pretty close with our stuff, so I'll assume we're on this. NGC 4517 twice. That's interesting. NGC 4517. Spiral galaxy 40 million light years away. Discovered by William Herschel in 1784. And that's all they say about it. Okay. Size 5 by 3, that's a nice size. This one is 10 by 1. PGC 41618. Interesting, they have different PGC numbers. And different UGC numbers. Different PGC and UGC numbers, but they're the same NGC number. So that's interesting. Oh yeah, and that's pretty accurate. 10 by 1. It's a pretty good size edge-on spiral. And this is actually the one that is pictured in Wikipedia, not this one. All right. Same NGC numbers. Well, I'm wondering if the NGC number on this is just bad. Could be a cataloging error. But anyway, a couple of interesting ones. Couple of interesting ones. Nice little spiral structure in here, though. Definitely got a galaxy out here. Not as numerous as what we've been looking at to this point, in terms of the background galaxies, but still some pretty looking ones here. Yeah, on my Stellarium it's also called Rainmouth. Rainmouth is supposed to be a comet. Rainmouth 1 is beside the upper NGC 45, so it's beside this one. And we have been photobombed. Go figure. Never even heard of the Rainmouth. Rainmouth. I don't know if that's a person or a catalog or what it is. Spiral structure, and then you can see a lot of dust lanes in here. A couple of neat galaxies. I guess it could be a little bit of a, looks like a little of the cigar galaxy, kind of a longer, skinnier version. Or the surfboard galaxy, which is another one we've done here recently. Another satellite bombing right through our upper galaxy. Well, where are we going to go next? I think I'm probably just going to do a couple more and call it. The Super Wind galaxy? Dust Devil galaxy. These don't look quite close enough together to do together. This is 4 and 2. Oof, this one's tiny. Well, there's 10 minutes with 2 satellites crisscrossing through the image. Let's try the Super Wind. Oh, Karl Reinmuth was a German astronomer in the early half of the 20th century. Huh. Got it. Well, there goes a satellite right through. Yeah, so we got that, but I don't think I'll be able to. I won't be able to get. Let's do a quick look and see what we can see of this one. Doesn't look like there's much of any image here in Stellarium. Another smattering. I'll do another couple. And maybe even catch an early next month one of the early next month. It's one of my first sessions next month. We'll try and maybe finish the last few. But we've mostly done it. The biggest patch is between Ursa Major and Virgo, and the Big Dipper and Virgo, and we've pretty much done it. There's still a good string of them in here, but and we'll see what we can see next month. All right, well there we are. 1, 2, 3 galaxies there, just in the first sub-exposure. 4th there. It's a little guy. And it doesn't look like they've got much of an image in there. What else? Definitely a spiral of some kind. Four 666. 466. Okay. Let's take a look and see, make sure we're okay here. Yeah, we're good there. NGC 4666. See what we have to say about you. It's a spiral galaxy, a distance of approximately 55 million light years. Discovered by William Herschel in 1784. It was described as bright, very large, much extended, 45 degrees plus or minus, pretty suddenly brighter middle. It's a member of an interacting system with NGC 4668 and a dwarf galaxy, and belongs to a small group that also includes NGC 4632. The morphological classification indicates a weak bar across the nucleus with moderately wound spiral arms. Viewed nearly edge-on, its galactic plane is inclined at an angle of 85 degrees to the line of sight from Earth, with the major axis aligned along a position angle of 40 degrees. Yeah, I don't think we're going to be able to see a whole lot of that. There is an active galactic nucleus that shows a modest level of activity and is most likely heavily obscured by gas and dust. The central point source has been detected in the radio and X-ray bands. It has vigorous star formation, which creates an unusual superwind of outflowing gas. This wind is not visible at optical wavelengths, but is prominent in X-rays. Huh, okay, so that's why it's called the superwind galaxy. Vigorous star formation creates an outflowing of gases. Cool. This actually got a little bit of shape to it down here. I don't think we're going to pick up much more detail from it, so I think actually I'm going to move along from that one. Go do the next one. I don't think we're going to pick up much more from that. So let's do 4753. The Dust Devil. No image in Stellarium. Oh, did I add that? Yes, I did. Good. Alright. Yeah, there it is up there. Let's bring it down a little bit in the frame. That's probably about right. It's probably a little too low, but... Alright. Let's see what we're doing. You guys are probably hearing that I definitely have had a little bit of a breeze picking up here in the last little bit. So this will probably be my last one, because this breeze is gonna just continue mucking up my images, and it's a little late anyway, so this will probably be my last one. 4753. Let's see what 4753 has. NGC 4753. Okay. NGC 4753 is a lenticular galaxy, located 60 million light years away in Virgo. It was discovered by William Herschel in 1784 and is notable for having distinct dust lanes that surround its nucleus. The galaxy is a member of the Virgo 2 group, an extension of the Virgo cluster. The distribution of dust lies in an inclined disk wrapped several times around the nucleus. The material in the disk may have been accreted from the merger of a gas-rich dwarf galaxy. Over several orbital periods, the accreted material eventually smeared out into a disk. Differential precession that occurred after the accretion event caused the disk to twist. Eventually, the disk settled into a fixed orientation with respect to the galaxy. The age of the disk is estimated to be around 500 million to 1 billion years. Yeah, I can see in the Hubble image, I can see the disk dust. I don't know that we're going to see it in my image, but we'll see what we can see. What else is in here? Any other galaxies around? Yeah, I think it's starting to thin out by this point. The outer part definitely has a shape. Yeah, I don't know that I'm going to be able to see much of that. Don't know that I'm going to be able to see any of the little wispy dust lanes and disk. I don't know that I'm going to get much more detail than that. Now let's try actually turning the stretch down a little bit. see any of the core by backing off on the stretch a little. I don't know. Well, actually, yeah, there's a little wisp there. Just right there's a little bit of a wisp. Of dark sort of trail there. Let's continue to play with the histogram and see if I can't tease out a little more. Yeah, see, now you can definitely see a little bit of a trace around it. Almost like dark ears on the core of the galaxy. I have to really, yeah, you can definitely see there's something there. Kind of goes around and then trails off right there. Looking at the Hubble image, that's what the Hubble image sees. You kind of got a swirl and then it kind of tails off like that. So we can kind of see them. Not very well resolved because it's really at the a little bit past the resolution limit of my camera. And scope, considering this is only a little 6-inch reflector. It's a little bit beyond it, but I think it's okay. Dull that core down a little bit more and you can see it just a little bit, but of course we lose most of the galaxy and most of the outer parts of the galaxy are lost to dim the core down enough to see that, but definitely looks like you can see it there. Yeah, Ollie, you did this requires dark skies to see this subtle a detail, and to see it well needs more scope and camera than I've got, but you can kind of see it, sort of see it in there. So Ollie, it's a little after 8 o'clock your time now. You headed off to work at any point? Are you not working today? Or maybe you're retired and just build hobby scopes now. First breakfast. Are you a hobbit? First breakfast, second breakfast, 11 Z's, and all that. You must be a hobbit. going to get much better than that. It's about as good as we're going to... about as good as it's going to happen. Brighten it back up, we get the outer extent, but then the inner core is all blown out. Yeah, you can kind of see it. Not too much work today. Oh, yesterday was a holiday. Oh, okay. Well, folks, I think that's going to be my last one for this session. Let's see where we're at here. I did not add it in yet, so let's add it. Doink. So now it is in there. Yeah, so now we've got all the way to the top of Virgo done. So maybe next month we'll do some of these. We've got M104 down here. So that would be an interesting one to do. Some of these other ones perhaps. We'll see. Smaller NGCs, but this stuff is anything that's over 30 degrees is fair game. And right now this is perfectly southern sky, so it's about as high in the sky as it's going to get. Next month it might be a titch higher because we're continuing, because the summer solstice is next month, so the southern sky is continuing to climb just a little bit. But yeah, so that's been 2 months of effort doing that. It's been a lot of stuff we got there. So anyway, yeah, good, Ollie. I hope I gave you some guidance about what to do next and what not to do. But yeah, thanks everybody for joining, and probably going to be done now for this bright of the moon that's coming up for the next couple of weeks. So I'll probably start again in a couple of weeks when right after, a few days after the full moon, and we'll be back to it. So thanks everybody for joining, and I will see you next time. Good night from Death Valley.